we're going to do the torsion test, and by the way, you have to wear eyeglasses, safety glasses. So make sure to ask your students to wear safety glasses all the time. This is for torsion test, and this is a product of Tina Olsen. This is stationary. This does not. In fact, this is stationary. This doesn't rotate. This one does rotate. It spins, and we measure. We have a steel specimen, and also we do have aluminum specimen right there. So the first step, like always, we're going to measure the diameter. And extremely important that you measure the diameter at 2-3 locations. So this is one. It's about 0.75 inches, but just make sure to double check that. So this is 0.747. Maybe here again, 0.746. And then maybe here again, 0.738. You can take the average. You just take one of them. It's your call. Okay, but maybe you should take the average. Okay, and basically, this machine is one of the weirdest machines ever. It's the only machine that I've ever seen doesn't have an on-off button. So this is my on-off, okay? So you plug it in, it's on, you take it out, it's off, okay? I looked around under the table around, there's nothing on-off for this guy here. So I'm gonna turn it on. And now, start working. If you look carefully here, this is the scale, which is in degrees. So now it's 0, okay? And you go this way or you go the other way, so it starts 10, 20, all the way to 360, 350, 360 here, okay? So that's very much a full cycle. What you need for this test, you need the strain indicator, the blue box. We have the strain gauge is attached at 45 degrees. So this is very much at 45 degrees, so it's not horizontal, you know, because the shear strain is going to be twice the strain at 45 degrees. So that's the reason here. Untie this guy. We're going to untie this. I'm going to move it slowly. I think that's the end of it. So that's what you have here. And then we are going to install it. First, let me untie all of those screws. So very much the way how we install this is like changing flat tire. So I'm gonna untie this, insert this inside, and then insert inside from the other side. So basically you have it now in both sides. You can also untie this if you like, and then move it forward. Did I say it's heavy? Okay. Okay, so now this is it again. Maybe it's a good idea to keep maybe space, so it's a little bit loose here. You can move it forward and backward, so that's the ideal situation. Just make sure that it's really inside. And then we want to tie the specimen, and we want to center it right in the middle. And you see those circles? If you see the circles, so very much you want to center that. This should be your guide to center the specimen. So those guys here, those screws here, very much they have to align at the same circle. And normally they end up at the second circle, so which means that you need to move this a little bit inside. So you tie this guy, and then tie this a little bit more. And I think I need to tie the other side. You can tie it with hand, by the way. And this is, you are very close. This is away from the center. So let's move it a little bit. They are all very much meeting at the second circle. So let me move it more. And then I'm gonna tie this more, tie this a little bit. And then let me tie this. Okay, there you go. So again, normally for this specimen, the 0.75 inches, the center is right at the second circle. Same thing we're gonna do for this guy, and this is very much almost right at the center. I'm gonna tie this. I'm gonna tie it really hard. And when I say tie it really hard. So I'm gonna tie this guy here. And don't worry, you're not gonna break the specimen, take my word. You're not gonna break the machine, which is most important. Okay, so I'm gonna tie this really hard again. There you go. Let me tie this thing here. I'm gonna tie this. Okay. And then I'm gonna tie this more. Okay, I'm gonna assume that. Okay. One thing extremely important that I always forget is to tie this thing here. You need to tie this. And now the specimen is secured. And we're ready to run the machine. The test, I'm sorry. So now if you look carefully to the handset, you read here pound inch, which is the torque, and also so inch pound, 196, and then the degrees, which is the twisting angle. Okay, so we are going to connect the strain gauge to the strain indicator. We're going to use the first channel. You have the two slots, so I'm going to put this is the first one, goes to the, doesn't matter the order, so you have that in the second slot, and then this one I'm going to put it in the first slot. And there you go. And now you can start to see a number there. So that's very much the reading. And definitely we're not going to start with that. We are going to zero the reading of the strain gauge. And to do that, you click balance. And then it says ready to auto balance. And the answer is yes. If you are ready, so you have to click balance again. And then it goes through the 4 channels. We only have one at the first channel. It says cannot balance channel 2, 3, 4. That's true because we have nothing attached to that. And then once it's done, it says save settings. The answer is yes. To do that, you have to press record REC. Record. I'm gonna save that. And now it's very much 0. That's 3, that's 0. Remember the reading from the strain indicator is 10 to minus 6. So if you read 10, that's 10 times 10 to minus 6. Let's go back to this guy. Before you start the test, you need to zero also the torque. You read carefully here, it says 0 torque. So I'm going to say 0. Okay. And then 0 position, which is already 0, but you can zero that also. Okay. And we're ready here. And I want to go back to the specimen again. I'm going to draw a line because when the specimen spins, it's really nice to see those lines spinning on the specimen surface. So, and we're going to draw this line. Make sure that it's straight. It doesn't look really nice on a steel specimen, but on aluminum, it looks really nice. So you have this guy. This is the red line. It doesn't look red, but it's red. So you have that. And then it's also the line on the other side. Again, you can see it really nice on the aluminum specimen. And steel, it's really hard to see on steel, but for aluminum, you will really see it. It's really nice. Okay, we have that ready. So now we are going to start the test. And the way how this works, it's really easy. I'm going to apply torque. I'm going to load it all the way to 5 or 10 degrees. Stop, read the torque, and read the strain. It's your call how you want to do this. But basically, you can do 5 degrees increment or you can do 10 degrees increment. And I prefer always to do for aluminum 5 degrees increment, maybe the first 10, 15, and then switch to 10, and then switch even to 20. For steel, I do most of the time 10 degrees increment for 10 specimen, 10 increment, and then switch to 20, and then maybe later even to go switch to 50 if you have the plastic region. And the way how you do that, it's really very simple. This is high clutch and low clutch. You can do either. So I'm gonna do high clutch. And once you do high clutch, it says here high. And then I'm going to click test. And now it says ready. I'm ready to test. And now it's your choice whether you wanna go forward or backward, clockwise or counterclockwise. It doesn't matter. So I'm going to go by forward. So I'm gonna go to forward. And now the machine starts spinning and the strain starts to increase. And at 10, I'm gonna stop. This is how you stop. This is the circle here. You click that, it stops. Now 10 degrees, and then the strain, the torque is 2092 pound-inch. This is my first reading. And then I'm going to read what is the strain, which is 1063 times 10 to minus 6. The minus doesn't mean a lot here for us. 1063 or 61 times 10 to minus 6. That's my first reading. And then I can go, so you multiply that times 2, you get the shear strain. I'm going to the next point. I'm going to load it to 20 degrees. So let me load it to 20 degrees. And to do that, you can just hit the circle again. So I'm going to go by the circle. And in fact, not the circle. You have to go with the arrow. So to load it again, you go with the same arrow going up. So now I'm going to 13, I'm going to 20. And I want to stop, you hit the circle. So about 20, you hit the circle. And now it's stop. You're going to read what is the torque, 3523. And then what is the strain, 1790 times 10 to minus 6. And now we're ready to go to the next step. And again, to go to 30, you have to hit the arrow exactly the same direction. So if you go forward, you hit the same arrow. So I'm going to the next reading, and you keep going. I don't know, up to the failure point. Again, the first 10 reading, I'm gonna stop here. First 10 reading, maybe at 5 degrees increment or 10 degrees increment. It's your call. And then you read that, and then you load it to failure. I'm gonna load it now to failure. Okay. So let me load it to failure. So, and the way how to do that, I'm going to put it back here. If you want to go a little bit faster, because at some point you will lose the strain gauge, because the strain gauge does not elongate for a lot. So you're going to lose the strain gauge. So you go, if you want to go really fast, you can hit this twice. So 1, 2, and now it's going really fast. Okay, and look carefully here. The line, which is the imaginary line, it starts spin here. So once it comes back from the other side, that's 360 degrees. And now you are at about 200 degrees. And very much you can read here, 200 here, also it's 200 right there. But we're going to use also the handset, just the handset. Once it is about 360, okay. At 360, which is very much one cycle, you will see the line, you will see that the red line comes out, which comes from the other side. And that's very much one revolution, one cycle. And that's what you see right there. It's exactly at 360. If you read, the strain gauge still can read things, but at some point we're going to lose it. Let's just keep going. Let me see what time, what level we're going to lose the strain gauge. Okay, 2200s and going. Talking about 7 revolutions. And now it's a good idea if you want to ask the students to touch the thing. It's a little bit warm and going to be hot. Now it's hot. So just be careful. I mean, maybe you can ask him about 1000 degrees to touch it, but now it's really hot. It is hot. Touch it. Okay, 2400s and going. So if you look carefully at the torque is not increasing. The torque is not increasing, which is very much the plastic region, while the degrees, the twisting, is increasing without increasing the torque. So it's like fluid. Good. And again, the red, the circle, I'm gonna stop it here. And the failure is about 3820 degrees of spinning. Just think about it. How many revolutions is this? I'm gonna take this out from, just put it in the back. Okay. And that's where it fails. It's right at the support. It's a shear failure. And very much that's the end of the test. Thank you.